All right. Two different probabilities. There's two different ones. Hey, everybody, I'm going to flip a coin. What's the probability I get ahead? 1/2? 50%? Everyone agree with that? I'm going to roll a die. What's the probability I get a 5? 1 out of 6. Those probabilities you are giving me are called theoretical probabilities, what it should be, right? That's what they're called. Now, let's say I do an experiment. Oh boy. Mr. Carlino. Hi, Jane. She is. You got it. Yeah, bye-bye. You're gone, Catherine. All right. God, I have to wipe everything down now. He sits somewhere else. All right. Like I was saying, that's called theoretical probability, what it should come out to be. Let's say I take a coin and I flip it 10 times. And out of those 10 times, I get, and you don't have to jot this down, 7 heads and 3 tails. The theoretical probability of getting ahead is still what? 1/2, right? But now, if I went based on my experiment, my results, it would be 7 out of 10, the probability I get ahead. That's called experimental probability. Okay, so after you do some trials, after you do an experiment, you base it off of those results. That's called empirical or experimental probability. Okay, everybody all right on that? Okay. Couple huge things that I try to drive home every year to kids, and I don't know if it gets through or not. Probabilities can never be negative. Okay, you can't have a negative 20% chance of something happening. So it can't be less than 0, but it could be 0. How do you have a probability of 0? What's the probability I roll a die and get a 7? It's not happening. Okay, 0. What's the probability? She's rattling me right now. Okay, you get 0, right? You could also have a probability of 1, which would mean it is absolutely going to happen. Meaning, I roll a die, what's the probability I get between a 1 and a 6? It's 100%. Okay? So anytime you give me an answer for probability, it better be between 0 and 1. You can't have a probability of 2, of 10, of 100. It's got to be between 0 and 1. Are we all good on that? Okay. What if I tell you the probability of some random event happening is 3 out of 5? What's the probability that event won't happen? Won't happen. 3 out of 5 it will. Won't happen. 2 out of 5. Everyone agree with that? That probability that it won't happen is called the complement of an event. Right? So probability I pick a 4, probability I don't pick a 4 will be the complement. Okay? And if I add the two together of an event happening and not happening, it'll total 1. All right? So again, please don't write down probabilities that are bigger than 1. Now, when I say bigger than 1, you could still have a probability of 43%. Well, that's bigger than 1. True, but as a decimal, what's 43%? 0.43. Is that bigger than 1? No. So you can still have probabilities in percent that are bigger than 1. That's fine. All right? All right, let's get right to it, because I want to start hearing some of you guys. Some of you guys. All right, here we go. Is this experimental or is it theoretical? Let me start with number 2. The chance that a fair coin is heads up is 1/2. What's that 1/2 represent? Is that a theoretical or experimental? You're up, Ethan. What do you got? That's going to be theoretical. Yep, that's what should happen. What about the weathermen when they predict the weather? So a guy gets on the TV. He's like, hey, 40% chance of rain today. What's he basing that probability off of? Lucas? Well, what he thinks and what type of data. So what type of probability would it be? From experiments. Yep, experimental. So 2 good examples of the difference between experimental versus theoretical. Okay, roll a die, 6-sided die. Isabella, rolling a 1 or a 5. What do you got for me? What's the probability of rolling a 1 or a 5? Well, hold on. How many 1s are on the die? How many 5s? So there's 2 total possibilities out of a total of how many 6. And she did it for me. Yes, every single one you reduce for me, please. Every single one you reduce for me. And I'll show you why in a second. Okay, so the probability is 1/3. All right, Matt, even number. How many even numbers are on a die? You sure? Didn't sound confident. You want to check? You good? Out of how many choices? 6, reduce it. So the probability you roll an even number, 1/2. Before we move on, don't flip that paper. Before we move on, notation, capital P there. We're in a new unit, so it's not period anymore, boys and girls. That's probability. All right, that's what that means. Probability, I roll an even number. Okay, so just if you see that, I don't need you freaking out. Anything you want to ask? Brooke, how you doing? Good to see you. Oh, we got some. I love this unit because it's just like the real life examples that come out are unbelievable. Wait till you see some of these today. Half-hour television not this one though. Half-hour television program. We got 8 minutes for commercials. If I randomly turn on the TV during a half hour, what's the probability that a commercial is not being shown? Well, I know 8 minutes worth of commercials, so not commercials there, Patrick, would be how many minutes? 22 minutes out of a total of 30. Yep. And like I've told you before, guys, let's reduce these. And that'll end up being 11/15. Everyone all right? Oh, now here's where we start getting real. Juices in the cafeteria. Before we find any probabilities, can I have a little gauge of the class here? Which one would be our top? Which one would be our bottom one? What are we thinking here as far as juices go? Wow, believe it or not, that would be my number one too, Lucas. That's the only thing we'll ever have in common. All right, hopefully. What would be your bottom one? Oh, get out of here. Never mind. No. Orange would be my number one without a doubt. It might be a tie, but I'd have to go with tomato. Tomato or grapefruit would be at the bottom. I'd go with tomato. Anybody at tomato would be their number one? Anybody? We won't judge. Yeah. You've never had tomato juice? Don't try it. Don't start trying. It's awful. Literally think of a tomato crushed into juice. Yeah, with a little extra flavor on it to make it even more tomato. Because right, that's what it tastes like. Yes. Anybody else have a favorite up here? No. It's marinara much better. I'd rather drink that straight up than tomato juice. All right. Anybody else up there got a favorite? Yeah, apple juice. It's not bad. Orange juice, yeah. Orange or apple. I still go cranberry, though. That's not bad. A little change of pace. Okay, so here we go. We got Marcel. Marcel going to pick a juice at random. What's the probability he picks an orange or a grapefruit? All right, so here's the orange. Here's the grapefruit. How many different outcomes do I have there with the orange or the grapefruit? 25 different outcomes out of a total of how many outcomes? If you add up all the numbers sold, it should end up being 40. And this is the classic example why I need you to reduce them. Because most likely on any test we take, including the Regents, all your multiple choice answers will be in lowest terms. So just get in the habit of doing it now. So 25 out of 40, your darn calculators do it for you. You don't have to think what number goes into each of them. And it should end up being 5 out of 8. 5 out of 8 chance you bought orange or grapefruit. Questions? And we got more too. I gotta need your opinion on. Not right now though, because we're just going back to flipping an old coin. All right, flipping the coin. We're gonna do it 3 times. 3 times. You guys remember, anybody ever done a tree diagram? Because I feel like some of the kids in third period did, some of them never have seen a tree diagram. We've heard of tree diagrams. Okay, might have been a long time ago, sure. Yeah. All right, so here's what I'm gonna do. I'm gonna draw a tree diagram of all my different outcomes, okay? So here you go. Flipping the first coin. What are the outcomes? I could have what are the outcomes of flipping the first coin? Head or a tail? Everyone agree? I could go a head or a tail. There are the possibilities for my first flip. Second flip. What are the choices? Okay, well, hey, what if I had a head first? Is that going to affect what the second one is? Okay, so here's how we represent that. If I had a head first, the second one could still be a head or a tail. Well, what if I flip the tail first? What's the outcome for the second coin still? A head or a tail. So before I go to the third coin, if you flip it twice, how many different outcomes are possible of heads and tails? How many different outcomes are possible as seen up here? 8. How do you get 8 from? And you can stop. How many did you just list me? 4. Okay, everyone good? 4? Everyone's good. 4. Yes? There's 4 different outcomes. Okay, here comes the third coin now. What if I got heads the first 2 tosses? What's possible for the third toss? Still a or tail. All right, well, what if you went heads then a tail? It's still what? Your outcome on the third flip. Head or tail, right? Keep going. It's always going to be a head or a tail on the third flip. So it was 4 for 2 flips. How many outcomes for 3 flips? Now there's 8, yes. You can count the lowest branch, 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, 4, and there's 4 over there for a total of 8. That's one way you can list it out. The other way is what's called a sample space, which you literally list out all the possibilities. So you can do a tree diagram to find the outcomes or list out the actual sample space. So for us, ready? I could go 3 heads, right? I could get all 3 heads. So that's represented by H, H, H. And when you list out a sample space, you literally list out every single combination you could have. What's another combination I could have? If you want to cheat off your tree diagram, go ahead. What's another combo? Because remember, we should have 8 total here. That's what I was thinking. Head, head, tail. Yep. Nice job, everybody. Head, head, tail. Oh, yeah, you're right. It could be head, tail, head. Yep, absolutely. And then too quick. Hold on. Slow down. Head, tail, tail. Yep. I'm catching up. And then we can do it, yep, starting with the tail first. Two. Two different ways of listing out all the outcomes, tree diagram or what's called a sample space. Most of the time, I will give you the choice. Okay, most of the time. Not all the time, but most of the time I'll give you the choice on how you want to list out all the outcomes. All right, now let's answer some questions now. Capital P for probability, I get all heads. So how many times did all heads come up? Once out of 8 times. Exactly 2 heads. Exactly 2 heads. So use your tree diagram. Let's see. Nope. Yes. Or use your sample space. Count up how many times exactly 2 heads popped up there. Vinny, what do you got? How many times? 3 out of 8 times. Is that true? I don't have my cheat sheet in front of me. Just 3. We're getting some drawback here, Vinny. That's correct. I'm getting 3. So tell your classmates to settle down. All heads or all tails? All heads or all tails? Reagan, what do you got? 2 out of 8, also known as 1/4. So you guys decide what you prefer, sample space or a tree diagram. All right, decide what you prefer. Oh, here we go, the school carnival. They still do those in elementary school or no? They got rid of them? Favorite, okay, here we go. Favorite game at the carnival. This is ring toss. Not my favorite. Anybody have favorites? Ring toss. Or you got to shoot the water into the clown's mouth, watch the balloon blow up. Darts with the balloons, popping them. Guess the weight of the bearded lady. No, nothing like that. Nothing. Nobody wants to. Their carnival games. Lucas, I'm sure you're all about it. Somebody said that third period too, yeah. The ping pong ball in the fish tank. Yep. Now, not really carnival stuff, but it's kind of along the same lines. Whack-a-mole. Anybody? I haven't done much research, but I wouldn't be surprised if I was world ranked on the whack-a-mole circuit. All right, no joke. All right, no joke. That's how I won this bad boy up here, Six Flags, probably about 5-6 years ago. Me and a 7-year-old. See ya! Gone. Don't come back when you got your A game. It's just up there. Reflexes like no other. I don't care how old you are. Get out of here. Get on my level. All right. So we don't have exciting prizes here, but we do have 2 sunglasses, 3 necklaces, and a keychain. Nice. And we choose them from a bag. John's the first to win. Find the probability. He chooses the keychain. Okay, well, how many keychains do I have? 1 out of how many prizes to choose from? How many prizes here? 6 prizes. And if this helps you out, usually sometimes I do this, especially with like different colors and marbles and stuff. I'll just put them in my own little prize bag. So 2 sunglasses, 3 necklaces, and 1 keychain. All right. And if we can, start getting the habit of doing the notation. So probability, capital P, and then however you want to represent keychain, I'll put K for keychain. But guess what? John did not pick the keychain. He decided to pick the sunglasses instead. So the next person up, what's their probability of picking the keychain now? Because it's not 1/6 anymore. It's not 1/6. Sunglasses are gone. John picked the sunglasses. So second person to win. How many keychains are in the prize box? Still at 1 because it hasn't been picked. But now how many prizes are in there? Not 6, but 5. Why are the probabilities different? Explain why the probabilities are different. Why is it 1/6 and 1/5? Good explanation. That's right. A second. How many more weeks do we have together? 30 too many? No. Not at all. What am I going to do next year without you guys? Probably have conversations. Who knows? Why are the probabilities different? Because the number of outcomes is 1 less, right? So number of outcomes is 1 less. Choice 4. I was going to say choice 5. Everyone doing all right? Great. All right. This is our last question, right? Coming up. Okay. I want to just get focused and serious here for a second because some of the kids don't get this one. All right. It's a little complicated. So you got a quiz. How many questions on the quiz? Anybody? students taking a quiz randomly guess the answers to 2 multiple choice questions. So there's 2 multiple choice questions, but each question has how many choices? 3. So think of it this way. Here's question 1, you got A, B, C. Here's question 2, you got A, B, C. How many right answers are there? 1, and how many wrong answers? 2. So you're telling me on the first question, you have 1 right answer and 2 wrong answers. You have a 1 out of 3 chance of being right. You have a 2 out of 3 chance of being wrong. Does everyone see why there's 2 W's up there? Because you have 2 chances of being wrong. Okay, there's the first question. Now you go to the second question. If you got the first question right, how many right answers are on number 2? Still 1, and how many wrong answers? 2 different wrong answers. You got the first one wrong. You picked one of the wrong choices. You could still pick the right answer or one of the 2 wrong answers. And the same thing goes if you pick the other wrong answer in number 1. You could pick the right one or any of the 2 wrong ones. I'll just let that simmer for a second because third period had a slew of questions for me there. Why we're setting it up that way. Because you get a 1 out of 3 chance of getting it right or a 2 out of 3 chance of getting it wrong. That's what I'm representing every time. Are we all right? Okay, what's the probability you guessed correctly on both questions? Well, Brienne, how many times does that happen? How many? Where are the 3? You guessed both right. Both questions right. Right? If there's any other time I come up, nope, everyone see that. You answer both questions right. First one right, second one right. That's the only time both of them come up, right? So 1 out of, how many choices there, Brienne? 9. You got a 1 out of 9 shot of getting both of them right. So think about that next time you take a multiple choice test and you just randomly guess on 2 of them. You got a 1 out of 9 shot of getting both of those right. What's your chances of getting only one of them correct? Only 1 correct. Ready? Go down the list with me. Would this count? Only 1 correct. No, would this count? Would this count? A right and a wrong. Okay, so keep the tally. There's 1. What about this one? Yes. What about first one wrong, second one right? Okay, we're up to 3. 2 wrongs. 2 wrongs. Nope. Right here. So I'm up to what? 4. Wrong. Nope. So how many total did I have? 4 out of 9. So if you blindly guess on 2 multiple choices, getting one of them correct, it's 4 out of 9. Right? Imagine if there's 4 multiple choices. Your odds are even worse. Anything you want to ask? Going. Chromebook, phone, whatever the answer key is provided on within your group right now. At least one of you have it open. Get going. No doubt you can finish this.